Alright, so this is take 2 because I recorded once, but then it turned out that my headset microphone is apparently completely dead now. So now I'm using a webcam microphone instead, and hopefully that works out. So as I explained in the original recording that you won't hear, I did not accomplish as much in this sprint as I had hoped to, but here is what I did manage to do. So I've made this enemy here. It's a sniper. It will shoot. It's not very intelligent. I've intentionally made it so that it doesn't see that there's a wall in the way, but as you can see, it still does hit me. And just because I'm upright doesn't mean I'm alive. I'm still very much dead. I have my own attack that I can use against him. There we go. There's also these patrol enemies that will just walk back and forth until they hit the wall on edge, and they'll also deal damage on contact. Let's see. So to quickly explain how everything here works, first of all, the camera is no longer part of the player. It's now part of a game master object, and the camera will now search for a player and attach it. And if it doesn't already have a parent object, it will search for a player and make them its parent object, but not using the actual Unity parenting anymore. There's a player UI. It's responsible for showing the hearts. Similarly, it finds a player and attaches itself to it, and then after that it just gets an update health method sometimes, and it will be told how much health it should put on display. I could make this just part of the update method, asking the player every frame, but didn't think that was necessary. Let's see. So the player here has a dash attack that I've added now, the fire dash script. I've also taken simple physics and made it its own script, separate from player behavior, and this simple physics script is also used by the sniper and the patrolman enemies. Let's see. So if we jump to the player behavior script, as you can tell, the player behavior has a lot more fields now. The fire dash, as you can see here, is simultaneously a mono behavior and a newly added interface, the power interface. The power interface just gives a few information about what it's supposed to be able to do, as you know, it's an interface. Start, the player finds all of its powers. So if I add or remove powers dynamically between levels or something like that, currently I have not managed to make the levels that I wanted to make. Still only have this one level used for demonstration. I would have liked to create a few extra, but it is what it is. But it finds all of its powers and it just assigns them buttons from the bottom row of the keyboard. Let's see, then we've got that's just how I'm doing it for now. I might very much change that later. It's got its iframes and a knockback timer. So iframes obviously tells it when it's invincible, and a knockback timer when it's currently getting knocked around, therefore unable to act. I'm now also measuring a vertical input, and I'm putting them together in a vector. Horizontal movement still uses horizontal input, but the fire dash uses this vector. Last input is not a vector I'm currently using, but it's what I thought I would be using, so that's why I started setting it. Then we've got this input locked and this vulnerable methods down here. is vulnerable. If we currently have 5 iframes, we're not vulnerable. If one of our powers is making us invulnerable, we're not vulnerable. Otherwise, we are input locked. If we're taking knockback or we're out of health, we are input locked. If one of our powers input locks us, we are input locked. And both of those are properties that the iPower interface promises, and the fire dash just implements by saying, am I currently dashing? Then return true, otherwise false. So in theory, a passive power could also exist. Let's see. Then this whole shebang you've seen before. Jumping the boolean has been replaced by jump state int, so that now we don't automatically assume that we are in either of the two parts of a jump when we're moving upwards, because sometimes knockback will give us positive speed, and in that case we're still using forward gravity. Let's see. Then here we just go through our powers, check if we've just pressed the button for the power, and if we have put the power on cooldown, and the power is available, if we have call the execute method on the power. And then if that power now action locks us, we stop checking for the remaining powers. Just in case the player manages to input 2 separate powers that will both action lock on the same turn. This prevents that. On the same frame, this will prevent that. We've got a method here, deal damage. It takes a damage object, damage, that describes information about the damage, more specifically the amount and the knockback, which is a vector. And you can just see here we take our speeds and we add the damage vector, and then we ensure that we use forward gravity, subtract the amount of damage taken from the health, and then we update the health on the UI, give iframes, and if we are out of hit points, that's when we then say physics are no longer enabled, and we then the simple physics are no longer enabled, because now we just use a rigid body to simulate physics instead, and that's how I created the ragdoll effect. Simple physics now also has a send message for when it hits a surface in either of its directions. Player behavior does use that, but Patrolman here uses it. When it gets the surface hit, it changes direction. And other than that, as it walks back and forth, it will do a box cast downwards in front of it to see if there's a hole in front of it, and if there is, it turns around. And it's a box cast because I've decided to make it wide enough that if it wouldn't actually be able to fall down into the hole, then it just walks over. And let's see here. Then each frame we also just check if we are currently colliding with the player. Let's see, and then if it receives damage, it doesn't even care to check the knockback. It just says destroy myself. And similarly goes for the sniper, it just destroys itself on the damage message. The sniper is probably the most complex mono behavior in this sprint. At the start, it does the standard stuff. It identifies the player, it identifies its physics. Then it says it has an awake boolean. If it's not awake, it will check if the player has gotten close on the horizontal axis, and if the player has gotten close, then it will become awake. And then it has the shoot cooldown. It's probably a bad name. It indicates how close it is to actually shooting, as you might recall the aim tracer that got slimmer and slimmer, and then it's shot when it became 0. When it wakes up, it also sets its aim direction to be the dead right or dead left, depending on where the player is, rather than just starting dead at the player. And then it also does a little jump. When it is awake, if the player is too far away, it stops being awake. Otherwise, if it's grounded, so it needs to actually land for the jump, it enables the aim tracers, and then it rotates. It finds the direction to the player, and then it rotates its aim gear, which is just a vector showing the direction it's currently aiming in. It rotates the aim gear towards the player. Then it draws a cast towards the player to check for, just for the sake of clarity, I should do it like this. It rotates the tracers to match, and it casts towards the player with raycast all, and then that towards the direction it's aiming in, and then if that overlaps with the player hitbox, it says, alright, player is inside, therefore get closer to shooting, otherwise go back to max cooldown. That's what this code does, and this is the code that then if we at the end say our shoot cooldown is at 0, we spawn a projectile, give the projectile information about just going in the direction we're aiming, and then we go back to max cooldown and do add recoil to the sniper. And the aim tracers, they have their fill amount just consistently set to match how close they are to shooting, to fill out. That's the narrowing part. And if we look at the upper tracer, it has an upper tracer and a lower tracer, which fill from top and bottom respectively. And together those just create a coherent tracer that fills from the center. And then for the recoil, we don't actually slow down before we hit the ground, so that's for this one. If physics grounded at physics x speed not equal to 0, slow down, more or less. Let's see. The projectile spawns. It sets, if it's not been told of an owner, it will check if it has a parent and set the parent to be the owner. Then it will ensure that its direction is normalized, set its rotation to match the rotation it was given, the sprite rotation to match the rotation of the vector that says which direction it's going, and then each frame it will just move in that direction by its given speed. Get a list of contacts, check if one of them has a rigid body. If it does, it assumes it's wall destroy. If not, it will send a message to what the object it hit, the deal damage message that I've shown that snipers, patrolman, and the player can all receive. So currently the sniper can actually kill patrolman, and that's probably how I want it to be. I might change it later, but for now I actually like it that way. And it sends a damage object. Again, the damage object that contains information about the damage it deals. And you can also see here that it at the start fills out its own owner from the list of things it can hit, because the bullet actually starts inside of the sniper. And then it also has a maximum lifetime that at the end it says if I've hit something that I should be destroyed because of, or if my lifetime has hit 0, I just destroy myself. The fire dash here, it's a power and it's an eye power and a mono behavior. So it has a dash timer it uses to keep track of its current dash. As you can see at the moment, the dash actually only lasts for half a second. And then you see here, execute if the player is currently holding a direction with the arrow keys, normalize the input vector and set our directions to that. Otherwise, default to dead left, dead right, depending on the player's dir. And this dir will also probably be what the player uses to display whether it's facing left or right once it has a proper sprite. And for now, deer is just whichever you hit last of left or right. Then we set cooldown back to max, set dash timers to max, set the speeds here, and then you can see action lock we return if we're currently dashing reaction lock, so the player can't do normal controls. And then after, technically every frame it casts update, but the update more or less just remove returns without doing anything. If we don't have if dash timer isn't a thing, and dash timer is of course set in execute, and then we just persistently set the player's speeds to match the vector. That way, if, for instance, you slid along a wall, you then go back to diagonal movement once you got out of contact. We say the player doesn't really have gravity unless we specifically ran out of time on this frame. Then we give give gravity back to the player. Then we get a list of player contacts and tell them all, hey, we're dealing damage. And that's what the player uses to damage the patrolman and the sniper. And then we use this method to spawn a trail after ourselves. So trail cooldown minus equals time to delta time, and then when trail cooldown is less than or equals 0, we spawn a trail, and then we add the trail gap to the cooldown. And all of this is just information, setting the trail's position to be hours, the duration of the trail to be the trail time for fire dash, and then we say go down to half size and half transparency before phasing. Trail effect here is a generalized trail effect I've created. So for now it's only used for the fire trail, but you could imagine it being used for other trails. And it will take a duration that it should last before it fades away, a scale it should scale towards during that duration, usually less than 1, but I mean, if you wanted to, you could also make it scale upwards, and a transparency change that it gets again over the duration, which it then uses this formula here. Oh, I don't need this debug anymore. To determine the weighted average between its original scale and its target scale, and similarly for transparency. And then once it's run out of time, it destroys itself. And yeah, I think that's about it for showcasing the code. So now I can just quickly turn all of this back on. See the sniper trying to shoot me, and if I move fast enough, as you can see, it loses track. Then I have the ability to dash, and I can, of course, if I want to, I'll just have this sniper kill me real quick. Bam. There we go. Yeah, so like I said, didn't accomplish as much this sprint as I wanted to, but we'll see where I go from here.